So what we're looking at is the impact of oil exposure on pelagic fish, so open water fish, and coastal fish. We look at mahi-mahi and red drum as the two model species, but really they act as models for anything coastal and anything pelagic. One of the strengths, I believe, of what we do is we look at everything from the molecular level all the way up through the intact animal, how the animal interacts with its environment, its prey and its predators, and ultimately the implications for populations and ecosystems. The reason we're doing this is we get a feel for what part of the animal, what part of the biology of the animal is impacted by oil. What is the most sensitive physiological process? And if we know that at the cellular and subcellular and even the organ level, we can make predictions about what's going to happen to the intact animal. And we can then more targeted and specifically test for those impacts. The coastal fish, the red drum, represents a lot of species that are sort of found near shore. It's an iconic species, a lot of people fish for them. They're recreationally really, really important. And ecologically, in the estuaries, they also serve a very important role. So that's kind of like it's a good choice. In addition to that, and that's to be perfectly honest, logistically, we have them in culture. We have broodstock, we have access to early life stages pretty much year round. And that facilitates the work we're doing. We work on both early life stages all the way up through adults. And on the mahi side, the pelagic side, the same applies. Mahi is commercially really important, it's recreationally important, it's ecologically important as one of the top-down controllers of pelagic ecosystems. And it's iconic, everybody knows mahi. You've had it, you've eaten it, it's very tasty. And it serves as a good model for many of the other pelagic. So all the swordfishes and the billfishes, the tunas, they live in the same environment. Their early life stages are very, very similar in terms of where they are and how sensitive they are. We've done side-by-side studies on tuna and mahi. Mahi is sensitive, but mahi offers the advantage that we can actually keep them in culture. We can spawn them in captivity, we can raise the offspring. In fact, we've closed the life cycle. We've had one spawn in captivity, and they spawn daily. So I think one of the most important things we've learned is that it's long been known that early life stages exposed to oil, they exhibit cardiotoxicity. So the heart develops poorly, the heart function in the early life stages is impaired. We've learned two things that I think are really important. One is that the perception that early life stages are more sensitive, or usually a lot more sensitive than adults, doesn't quite hold true for these effects. When we expose the adults to even low levels of oil, we also see that their cardiac function is impaired. And what we're interested in now is looking at what does that mean for the animal in the wild. They don't die from this. They show almost no phenotype in the lab, but we do see that there's a reduced ability to swim, there's a reduced cardiac function, and we're now curious about what does it mean in the wild. The other thing we've learned is that in addition to cardiotoxicity, we see that sensory function, vision, and olfaction is impaired by oil exposure. And we have evidence now based on gene expression studies and behavioral studies that cognitive abilities, so the ability of the animal to learn and process information, is reduced after oil exposure. And the really cool thing, or scary thing, depending on your perspective, is that the cardiac effects from oil exposure and the cognitive impairment during oil exposure that we see in fish have also been reported in humans that are exposed to PAHs during early development. So what we learn in fish here is important for understanding what's happening in the Gulf of Mexico, but it may also have really important implications for understanding impacts of PAHs on human health. And if you think of it, brain function and cardiac function are very conserved functions throughout the animal kingdom, and certainly invertebrates. So what we're learning from fish here applies most likely to humans as well. We're still building this legacy. We've learned, and this is one of the things that I think applies to many people that are working on the deep water rice and oil spill in the Gulf, because we're working on animals that were poorly studied to begin with. So in fact, every time we do an experiment and we look for an oil effect, whether there is an oil effect or not, the control measurements of these animals is novel information. So one of the things we've learned is that mahi, for example, have some of the highest heart rates of any fish measured out there. Heart rates up to about 180, which is very, very high for fish. We know that, this is brand new data, we know that they migrate about 100 kilometers a day, up to 100 kilometers a day. So they cover immense distances. And we can actually, based on the laboratory experiments we have, where we know what the metabolic cost of moving for these animals is, we can now calculate the amount of energy that mahi will require in the wild to perform these migrations. So these are just some of the examples that we're learning. We're learning so much about the basic biology of these top predators that exert a very strong control of the ecosystems in the pelagic Gulf of Mexico. So I think, we've learned so much in terms of the basic biology of the system that's really valuable.